Hello everyone and welcome to African Tech Gurus. This is your number one channel where we learn technology by actually doing. Today we are going to cover preprocessors, the concepts behind it, go through the quiz and figure out how to do the tasks. And just make sure you've gone or watched the resources that we have provided. Either read it or watch it. This way it will help you understand what you have learned before and what you're going to learn even ahead in the future. So today we're just going to cover what we need to understand in today's task, and I'm just going to do a very brief um summarized and condensed version of the content that we have today, which is preprocessors. And I'm just going to show some preparation that I have over here. So generally, if you've worked with GCC before, you will remember what GCC does, and it mainly has four processes or four steps that are in the entire GCC compilation process. um, it usually starts when you have your source code, which can have any extension. It can either be a .c file, .cpp, which is C++, or a .h extension. And your source code is the code which will is the file which will contain the actual code that you have typed out. So that is the code that you have. So here we're going to specifically look at C code. So the next step that happens once you have your source code and you want to use GCC to compile it, there is something that is called a preprocess step. So what happens here is it is an intermediate step between your source file which you have provided and the compilation step. And what happens here, which is now the part of GCC, the source code is actually processed before the actual compilation. So it's like preparing the source code that you have. And what is this preparation? What is included in all this preparation that we have? So remember, in your source code, you might have header files that have been included or macros that have been included. And these header files may contain um, other functions inside it or other pieces of code that are inside it. So basically what happens is the GCC step, what happens here at preprocessor step is it takes your source code and the specific header files or macros that are inside there, and it expands those macros and includes them in the source file or source code that you have. So remember, your source code or your source file will have very condensed header files which will contain a reference to the bigger block of code that is somewhere else. So what happens is it takes that entire piece of code, the many lines or the few lines, and brings it and inputs it into your file, which is now your source code. So you'll have your source code and add on top of it the macros that have been expanded, the functions that have been expanded, and it is included. And what happens after that is you get an output, which is a file that contains a .i extension. So it is that simple and it's not very complex. So what happens is, for example, you will have your preprocessor directives, for example, hash include, which might include a specific library, for example, standard input or output, which is a library that contains more blocks of code that helps us to input or output message into the display for the user or for us to actually look at. And it also contains other conditional compilation directives, and it can be anything and that has been provided before. So there are some specific header files that are used. And why are they called header files? They are called header files because they are usually at the very top of your source code, and they will contain other functions, libraries, or macros that will help in further compilation and generation of your code. So the next thing that will happen is you will have your .i file move now into the compiler stage, which is now the generation of the assembly code. So this is after pre-processing. So once the preprocessed source code, which now has a .i extension, is fed into the compiler, it will translate the code into assembly language instructions for specific that is specific to the target architecture. So remember, assembly language instructions are very specific to the different architectures that are present in the different machines that we all use. So it will translate the .i extension file, which has the code, into assembly code, which now the computer or the device can understand depending on its architecture. So that will have a .s or .asm extension, which will now move into the next step, which is the assembly step, which is done by the assembler. And what happens here is the file which was provided previously is now used to generate machine code, which now the machine can interpret. So all these steps from the source code all the way to our um, generating our machine code at the assembler step, just helping us come up or break down the code that we have into a language that the computer can understand, which is machine code, which is basically zeros and ones, because that is the language of a computer. And lastly, what happens is the object file, which is now produced after the assembling stage, is now linked either statically or dynamically using a linker. And once the linking step happens, we have an executable file, which will now contain the executable machine code together with the specific libraries that are required to run this specific program. So that is the simplest way of explaining the GCC process. And today we're specifically looking at the preprocessor step. So today we are zeroing into the preprocessor step. So let us take a look at that. So specifically, as we are going to look at the preprocessor step, we are going to look at the preprocessor directives, a few of them, and how we can use them, especially the define. And we are also going to look at macro expansion. So we are going to look at specific macros that how we can use them, how we can create them, and the different ways they can be useful for us in the day-to-day coding, and how they can be generally useful in our journeys as software engineers. So generally, a macro or an object like macro, it's like an identifier which later on or wherever we place it in our code will be replaced with a bigger chunk of code, or it will be used to reference to another piece of code that is somewhere within the code. So why it's called object like is because it has a data like um, use or view to it, and they are very commonly used when we want to use it symbolically in to name numeric constants. So it's very useful when we want to use or create variables which will not change at any particular time, and these are constants. For example, the formula for calculating the area, or the a very good example is the area of a circle. So you use the pi r squared. So the pi is a value that never changes. So that is a numeric constant. And instead of typing each and every instance in your code, the value which is 3.1415, I believe, you can just use an object like macro, create a macro for it, and every time you want to reference or use that pi in your formula, you simply use the name of that variable, which is your constant per se, or your identifier. So when we are going to create macros, we are going to use the define directive. So this is one of the preprocessor directives that we will use to create macros. You can use so many, but today we're going to focus on this. And there are also very many other preprocessor directives which are very useful, and they're most of the time they're used at the very top of your source code to include other libraries or other files as well. So we will use this followed by the name of the macro that we want, and then the token or the sequence of characters that we want, be it a string, be it a single value, whatever it is, we are going to use that. So this is the general syntax for creating a macro. We use the preprocessor directive, which is define. This is the name of the macro, and as standard procedure, you use caps with your macronyms, such that if you are using the same name in your code later on as a variable, you're going to most likely use small letters, so you're able to differentiate the two and you won't be confused. And the last thing is the value or the token sequence that we want to assign or to have the macronym have reference to. So it's as simple as that. So for example, here, if we define a macro which is named buffer size, and we have it as an abbreviation for the token 1024, it means that 1024 will be stored in buffer size. So each and every single time we are going to use the term buffer size in our code, it is going to retrieve or be replaced with 1024. So it's as simple as that. So here we have another example, which is this. So what this is happening is it's just going to recognize that we want to create a memory location that has 1024 in it, because remember we have 1024 which has been allocated to buffer size, and here we are using buffer size and we are referencing buffer size. So at the end of the day, this will be the output. Where buffer size is, it will be replaced with 1024, which is the constant that we want to have each and every time we use it in our code. So the other way that you can use is, instead of writing or using your macro in one line, you can use it in multiple lines. And how you do that is you use define, which is the directive, preprocessor directive, the name of the macro, and the token sequences that you want. So here we want numbers to have 1, 2, and 3. And instead of putting this all in one line, we can put it in multiple lines. So we'll put 1 on the first line, press enter, and then have it on the second line. But before we put it in the second line, we need to have a backslash for the new line. So when it is expanded, what will happen, which is here, where we are creating an array of numbers, and what we want to have in the array is the numbers that we have defined previously in our macro using the define preprocessor directive. It will have 1, 2, and 3, and this will be your output. So this is what you will have to see. So you're not restricted to just using one single line. You can use multiple lines, and this gives you the flexibility to have a macro that is as big as you'd want it to. Yes. So if we look at an example that we have over here, we do have a program, a C preprocessor that scans your program sequentially. And here what we want to look at is what will be the output of this specific program. So here we are assigning x to a variable called foo or 4. And the next thing that you're going to do is we are creating a macro which is called x that contains or has reference to value 4. And the next thing that you're doing is we are assigning x, which, as the previous line has done, it contains the value 4, and 4 will be stored in the variable which is called the. So when we run this, what it gives us is, it's simply this. We have 4, which contains the variable or the character x, and we also have a variable bar that contains value. Yes. So generally, when preprocessors expands a macronym, the macros expansion replaces the macros invocation. Then the expansion is examined for more macros that are maybe present for it to expand into. So this might be a little bit complex, but if you want to understand this more, maybe look at the reference of Russian dolls or Russian roulette dolls. So what happens is you have a series of dolls that are nested inside each other per se. So here you have a macro that has reference to another macro inside it and another macro inside it until it reaches the very end where it gets the macros invocation. So that is what they're talking about here. So for example, what we have here, we are defining a macro called table size that is having reference to another macro called buff size. And where is buff size defined and invoked? It is in the second line, which is this, where we're defining a macro called buff size that should contain 1024. So when you call or when you invoke table size, it will first open up buff size and then realize that buff size is also a macro, and then open it up and realize that buff size contains 1024. And at that point, there is no other macro to expand into. And all these macros have been referencing to a value called 1024. So it's as simple as that. So don't be overwhelmed. Just take it in bit sizes and just make sure you understand these concepts. So let us say, for example, you have already defined a macro, but you now want to undefine it. And how you can do that, if we are to look at this example that we have over here, we have defined a macro called buff size that contains 1024. And then the next thing we have done is we have defined a macro called table size that contains buff size. And then we've gone ahead and undefined buff size. So buff size contains 24. So now we don't want it to contain 24, but we want it to contain something else. So we need to undefine it first. Because remember, a constant can only contain one value at a time. And this is one of the ways to do that when you're using preprocessor directives, which is now in this case undef, which will help us undefine the macro. So the next thing that we will do is we will go ahead now and define our macro buff size to contain the value or the character sequence that we want, which is now 37. So what happens when we call or when we want to expand table size? It will first open up into buff size, which is what it is containing. And then once it realizes that buff size is also a macro, it expands buff size and it realizes that it has 37. So that is a very simple way of using macros with the different preprocessor directives that you might want to use. And you are not limited to only using it in one line. You can use it for multiple lines, and with this you have the power and the flexibility to use it for so much more. You can also use it to create functions instead of creating the functions in the body or creating other files for the functions, but that is an extra step. I believe that it's covered somewhere. But if you also want us to look into that, please comment down below and we will definitely do that. But today we really wanted to make sure that we've been able to understand how we can use the preprocessor directive, which is defined and undefined, and how we can create object-like macros using this preprocessor directive. So thank you so much for watching today's video. If you've subscribed, thank you so much for subscribing. If you've watched until the end, thank you so much. Hope you're learning. And if you're new to this channel, please subscribe. We really appreciate the support. Tell us what you'd want to see more of. And until next time, happy coding.